Couple of note cards today. First one is number 9. And the title is Midpoint Formula. So yesterday we had a formula that was called the distance formula. And that was when you have 2 points and you want to know how far apart they are. If you want to know the length of that, that's the distance formula. Now today we're going to have a midpoint formula which finds the point that's in the middle. Okay, so the midpoint formula is used to find the coordinates of the exact middle point between 2 other points. So this formula that we're going to learn today is used to find the coordinates of the exact middle point between 2 other points. So just like yesterday, we're going to start out with 2 points. And the points are x1, y1, and x2, y2. And remember, this is not squared. Kind of looks like squared, but if the 2 was up above, it would be x squared. But this is just saying, hey, in this problem, there's 2 different x's, and this one is the second x, and this one is the first x, just to specify which is which. Okay, so back to yesterday. When you're finding the distance between 2 points, what do you do? Like, how does it start? Yes, Matt. Good. You subtract this and this. So there's 2 things to key on there. First of all, you're subtracting, and second of all, you're starting with the y's. So the midpoint formula is going to be different. We're going to start with the x's instead, and we're not going to subtract, we're going to add. Okay, so the midpoint formula is x2 plus x1. So comparing this with the distance formula, there's 2 differences. First, we're adding instead of subtracting. And second, we're starting with the x's instead of starting with the y. Okay, but the midpoint formula after that is easier. All you have to do is divide by 2. And then there's a comma. And you do the same thing with the y's. y2 plus y1 divided by 2. And then there's parentheses around that because it's a point. Okay, so this formula that I just wrote down will find this point that's in the exact middle between those other 2. That's it for number 9. So now moving on to note card 10. And the title is Perpendicular Lines. Perpendicular lines are lines that intersect. In other words, they hit each other. Lines that intersect at a 90-degree angle and make a 90-degree angle. Perpendicular lines are lines that intersect and make a 90-degree angle. So that would look like this. One would be coming across like that. The other one's coming across like that. And then they're hitting each other. And also, when they hit, they make a perfect corner, a 90-degree angle. That's what perpendicular lines are. And the symbol for perpendicular, this is kind of weird, it's an upside down T. So sometimes we're trying to be shorter and we don't want to write out the word perpendicular. So mathematicians made up this symbol, and that means perpendicular. We had another concept called parallel. The symbol for parallel is, it's kind of like an equal sign, except it's sideways. Yeah. So the symbol for parallel is just two lines going up and down like that. What are parallel lines again? Yeah. They go on forever. They never intersect. One more thing that we added this year. Yeah. They're coplanar. They're on the same plane. Good. So here's some example. You know what parallel lines look like, but here they are. They go on forever. They never intersect, as opposed to perpendicular lines, which do intersect. And they have to be on the same flat surface. Yeah.
You may have already covered this, but I agree. Just add, can parallel lines be line segments where like they just go in one direction?
I think sometimes we say line segments are parallel. But, I mean, technically they wouldn't be parallel lines, they'd be parallel segments. But yeah, you could have those stop. And I think you'd still call them parallel. Yeah. Okay, so parallel lines. Now, to contrast that, remember we had skew lines as well, where there was a line going this way, and there was a line going like up and down. So, like this. These are never hitting, but they're not on the same flat surface, so they're called skew. Parallel, never hit on the same flat surface, so coplanar. Skew is never hit, but on different planes. And then perpendicular is they do hit, and when they hit, they make a 90-degree angle. Okay, now we're going to talk about slope, which you haven't talked about since last year. These two lines are parallel, and they have the same exact slant, the same steepness. So that means they're going to have the same slope. So parallel lines have the same slope. So that means if this line's going up 3 over 2, so its slope would be 3 halves, then this line's going to be doing the same thing, up 3 over 2, slope 3 halves. So they have the same exact slope. If this one's 4 over 1, this one's 4 over 1, because they have the same steepness or the same slant. Which makes sense, because if they had different slants, then eventually they would hit. So if they're never going to hit, they have to have the same slant to them. So parallel lines have the same slope. And then we're going to contrast with that with perpendicular lines. Perpendicular lines have opposite reciprocal slope. perpendicular lines have opposite and reciprocal slope. And that's a little bit confusing to people, so I need to explain what opposite and reciprocal means. So first of all, what does opposite mean? It means one of them's positive and the other one's negative. So if one of the numbers is 2, the other one would be negative 2. That's opposite. Okay, and then reciprocal means that the fraction is flipped. So if this fraction is 3/2, then the other one is 2/3. And with perpendicular lines, both of those are going to happen. They're going to be both opposite and reciprocal. So one example would be if one of the lines was 2/5 for slope, so maybe this one is going up 2 over 5, up 2 over 5, then this one would be negative 5/2. So it's negative because that makes it opposite, and it's reciprocal because it's 2/5 to 5/2. And you could tell up here that this one, if it has positive slope, this one should have negative slope. And then if we graphed, we could tell that if this one's going up 2 over 5, this one needs to go down 5 over 2. Okay, so perpendicular lines have opposite reciprocal slopes. All right, that's it for note cards. Thank you for getting that down. I'll pass out the whole punch so you can keep yourself organized and also get out your paper, please. So the title today is Coordinate Geometry Day 1. And we are going to start with number 3. So you'll have to go back later and do 1 and 2, and notice up there, there's a question numbered 1/2. So you have to later do 1/2 and 1 and 2. But we're on number 3. Okay, so it says 5, 9 is the center of a circle. All right, so to help with our visualization, draw a circle on your page, on your paper. And then the center of the circle is right in the middle. And apparently that's the point 5, 9. So that's the first sentence. 5, 9 is the center of a circle. Okay, then it says 8, -3 is a point on the circle. When they say on the circle, they mean on the outer edge. So out here maybe, on the outer edge, is the point 8, -3. All right, so that's the first two sentences interpreted. 5, 9 is in the center of a circle. 8, -3 is on the outer edge. Okay, then the question is, what is the length of the radius? So what's a radius of a circle? Yeah, Connor?
Half of the diameter.
Good, half the diameter. All right, and so then that begs the question, well, what's the diameter? Yeah?
The distance across.
The distance all the way across the circle. So the radius is going to go from the center out to the edge. And it doesn't matter which way you go. All the radii are the same. So you could go this way. But since we have this point down here, I'll draw in this radius here. So that's a radius because it goes from the center of the circle to the outer edge. And the question is, what is the length of the radius? So I'm going to label that R for radius since we don't know what it is yet. Okay, so in order to find the length of the radius, what formula are we going to use? Yeah.
Isn't it just 2R?
Well, if we knew what the R was, so you're on the right track. If we knew that this was 7, then we could multiply it by 2, and then that would tell us that the diameter was 14. So in your head is a formula that connects the diameter to the radius. And that's good information. The problem is we don't know how long the radius is, so we can't multiply it by 2 to get the diameter. Plus, the question's not asking what the diameter is. The question's asking what the radius is. But that's good, because you got some information in there that's coming out. There's nothing wrong with that. Okay, so what formula are we going to use to figure out the length of this radius? Yeah. Distance formula. Good. I'm glad you said that. Some people would think, hey, I just put this formula on the board today, so that means we're going to use this one. But that's not the case in this problem, because this problem is asking for the length of the radius, right? And this formula doesn't give you length, it gives you midpoint. So if it's asking for the length, the answer is distance formula. Okay, so the distance formula is y2 minus y1, so negative 3 minus 9. So with distance formula, you subtract and then square. And same thing with the x's. Take 8 minus 5, so subtract and then square. So I'm subtracting the y's and then squaring, and then subtracting the x's and then squaring. And then after that you add, and that equals the distance squared. Okay, so that's the setup. Now we're going to go ahead and subtract. So 8 minus 5 is 3. So that comes out to 3. And negative 3 minus 9, that's tougher. It's negative 12. So from this step to this step, all I'm doing is subtracting, just to go systematically. So then I'll recopy the squared and the plus, and this squared, and this equals, and this r squared. Okay, now I'm going to square everything out from this step to this step. So 3 squared is 9, and negative 12 squared is 144. Remember to watch out for the fact that you might accidentally put a negative here. Negative times negative is positive. So that equals the r squared. And then 144 plus 9 is 153. And then last but not least, you take the square root. And today I'm going to go ahead and get that number. Figure out what the square root of 153 is. You got it?
It's well, it's a radical, but it's 12.3693 160.
All right, so let's go with 12.4, I guess. So sometimes we leave it as square root 153, but today the question was how long is the radius? So I want to know that that's 12 centimeters or whatever it is. Okay. Moving on to number 4. Number 4 says 10, 14 and negative 6, negative 8 are the endpoints of the diameter of a circle. All right, so we've got another circle. And the diameter of the circle goes all the way across through the middle. So on the last problem, we had a radius that just goes halfway across through the middle. This time we have a diameter that's all the way across through the middle. Okay, so this is 10 comma 14, and this is -6, -8. So that the end points, so the end points of a diameter are those. Okay, this time the question is, what are the coordinates for the center of the circle? So which formula should we use for this? Yeah. The midpoint, right? Because the center is going to be in the exact middle. So this is the new formula. Okay, so the way the new formula works is you start with the x's. So 10 and -6. And you add. So it's 10 plus -6. That's different than the distance formula where you subtract. In the midpoint formula, you add. So 10 plus -6. And then you divide by 2. And then there's a comma. And then you do the same thing with the y's. 14 plus -8. And divide by 2. Okay, so remember I like to do things systematically. So from this step to that step, I'm only going to add. So 10 plus -6 is 4. And 14 plus -8 is 6. And then I got to eventually divide, right? So divide by 2, divide by 2. And then to get the final answer, you finish out the division. So 4 divided by 2 is 2. 6 divided by 2 is 3. So 2 comma 3 is the point that's in the exact middle. So I can label it in my picture. And that means it's the center of the circle. Because the center of the circle would be in the exact middle between these two endpoints. All right, number 5. While playing football, Graham punts a football from his team's 15-yard line, 10 yards from his team's sideline. Okay, so I guess I got to draw a football field. Here's the 100 yards, and then here's the end zones. Okay, so he punted from the 15-yard line. So that's a little bit out here. So this is 15. 15-yard line means 15 yards from the goal line. And then where he punted was 10 yards from the sideline. So here's the sideline. So 10 yards in from that. This is where the punt happened. 10 yards from the sideline, 15 yards from the goal line. Okay, then this guy's a pretty good punter, better than a lot of NFL kickers apparently, because the ball landed 83 yards further down the field. Okay, so it went all the way down here. Yeah, he's a good punter for sure. 83 yards down the field, and then it also went diagonally because it ended up 25 yards from the sideline. So it started 10 yards from the sideline, but it ended up 25 yards from the sideline. Okay, and then the question is, how far did the football travel? So that's that whole distance here. We're assuming it went straight. That whole distance there is how far it went. So I'm going to call that D for distance. That's what we're looking for, how far the football went. Okay, now you might notice that in this picture there's a triangle. It's right there. And it has a 90-degree angle in it, which is good news because when a triangle has a 90-degree angle in it, then you can use Pythagorean theorem. Okay, so we know this is 83. Now, this is 25 in total, and this little bit is 10, because that's 10, right? So I'm going to split up that 25. This part's 10, and that part's 15. Because then it's a total of 25. So again, since we have a right triangle, we can use Pythagorean theorem. So legs squared plus legs squared equals hypotenuse squared. So 15 squared is 225, and 83 squared is pretty big. I think it's like something like 6,000. I did it last period, but I don't remember. Yeah, 6,889. So then you add 225 plus 6889, and that's 7,114. And then you take the square root. So like I said, this guy's a really good punter. He punted at 84.3 yards. Okay, so one of the things that's tricky on this paper is, a lot of times in math class you learn a new formula and then you just use that formula over and over and over again. So you don't really have to think about what formula you're going to use. But, yeah, on this paper we got 3 formulas. And so you have to think about, this one was the length, so that's why you did distance. And this one was the center, so that's why you did midpoint, the new one. And this one was a right triangle, so that's why we did Pythagorean theorem. All right, we're going to look at number 8 next. All right, so number 8 says find the value for A, given that the points 4 comma A and 1 comma 6 have a distance of 5. All right, so which formula are we going to use on this one? Distance formula, because it says it right there, right? Distance of 5. Okay, so distance formula, you subtract the y's. So the y's are 6 and A. So that's kind of weird. It's going to be 6 minus A. We can't figure that out, but just write it down. And then you also subtract the x's. So 1 minus 4. Okay, so we subtracted the y's, and then you square that. And we subtracted the x's, and then you square that. And then you add the answers. And then they told us that the distance is 5, so we can equal that to 5 squared. So this problem is a little bit different because usually the thing we don't know is right there. Usually we put d squared there. But this time the distance is 5, so that's why we're putting 5 there. And what we're looking for is this number over here. So it's a little bit different, but I'll show you how to do it. So we're going to work our way down. 1 minus 4 is negative 3. 5 squared is 25. So I'm just trying to figure out what I can figure out. I can figure out 1 minus 4, and I can figure out 5 squared. But I don't know what A is, so I can't figure out 6 minus A. So I'm just going to leave that for now and hope that later it'll work out okay. Okay, then negative 3 squared is 9. So I could figure that part out. But then I'm still stuck over here. Okay, so at this point right here, I'm stuck going forwards. Can't figure anything else out. I don't know what a is, so I can't do 6 minus a. So when you get stuck going forwards, what do? You start going backwards and get rid of stuff, right? So we're going to get rid of this plus 9 by subtracting it. If I subtract on both sides, then I'm okay. So that'll cross that out. And I'll end up with 16 over here. And then I'll just recopy this, because this stuff went away, but I still stuck with this. All right, so subtracting 9 got rid of plus 9. Now I got to get rid of squaring. So I'm going to take the square root, because that'll cross out the squaring. And when you take a square root, you get 2 answers. One of the answers is 4. So 6 minus a could be 4. But also the negative 4 is a square root, because negative 4 times negative 4 is positive 16. So it's also possible that 6 minus a is negative 4. So then you subtract the 6 over. And divide by negative 1. So on that answer, a comes out to 2. Same thing here, you subtract the 6 over, and you get negative 10. And then if you divide by negative 1, you get 10. So this one has 2 different answers in it, 2 and 10. The reason it has 2 answers is because it's quadratic. Doesn't look like it, but there's an a that's being squared. Anytime you have a quadratic, it's going to be 2 answers. Now, this one was nicer than some quadratics because we didn't have to factor or do quadratic formula. That's because there was just one letter. So we could square root to get rid of the squaring. Just as a reminder, like if you had x squared and regular x, that's when you'd have to do quadratic formula or factoring to solve it. This one was easier than that. Still kind of a pain though. All right, I'd also like to look at 9 with you. Number 9 says the Greek letter delta is a triangle, is sometimes used to represent the difference or the change in a pair of values. So for example, if you subtract 2 x's, you could write that as delta or triangle x. Okay, so when you subtract 2, usually we do x2 minus x1 instead of x1 minus x2. Like if x2 is 6 and x1 is 2, then the change is 4. If it changes from 6 to 2, then the change is 4. So when you subtract, you get what's called the change in the x value. So I'm just explaining what this triangle symbol stands for. It stands for change. So then if you subtract the y's, like if this y was 10 and this one was 2, the change would be 8. So y2 minus y1 is the change in y. Okay, so that's some new information. The triangle means change. It's the Greek letter delta. Okay, so then the question is, rewrite the distance formula using this new notation. Okay, so the distance formula is a big formula that we learned yesterday, and so we're going to try to shorten it down. Okay, so the way the distance formula goes is it's y2 minus y1 and then squared. But we have this new symbol for y2 minus y1, so we can write change in y squared. So on your note card, we wrote y2 minus y1 squared. But now on this problem, we're writing triangle y squared. It means the same thing, because triangle y stands for y2 minus y1. And then there's a plus sign in the distance formula. And then triangle x squared equals distance squared. So this is the distance formula, but it's just rewritten in a different way. Now this one is nicer because it's shorter. But then the downside of it is you might forget what the triangle means. So the other one is longer, but there's less to forget. So it's kind of a trade-off. Some people like this one better because they are confident that they're going to remember what the triangle means. But some people like the one on the note card better because they're not confident that they're going to remember what the triangle means. All right, so you got to go back and do 1/2, 1 and 2, and 6 and 7. Thanks for paying attention.